The bottom half of page 2 is talking about compounds that contain polyatomic ions. And this is really when you have just multiple nonmetals bonded to your single metal. So when there's more than one nonmetal bonded to the metal. So 2 or more nonmetals bonded to the metal are going to be called polyatomic ions. That's this word right here. And when we write compounds that contain polyatomic ions, we do the same thing that we've been doing this whole time, which is crisscrossing their oxidation numbers to tell you how many of the other ion you need. So you're going to use the charge given to a polyatomic ion, which applies to the entire group of atoms. The polyatomic ion exists as a unit, and you will never change the subscript of the atoms within the ion. And if more than one polyatomic is needed, you will place parentheses around the ion and then write the appropriate subscript outside the parentheses. So we can use the polyatomic ions chart in our notes, or I gave you the same chart in your periodic table or on your periodic table. So we've been seeing this all year long. If you've been wondering what those are, these are called your polyatomic ions, and we can also describe it up here. So this is just when you have multiple nonmetals that are combined as a group, and they all have a total overall charge. When we do compounds with them, so if we write the formula, that's a combination of sodium and nitrate. My metal in this case is sodium, so when I write that symbol, it's just Na like it has been in any of our compounds. And then I'm going to use the periodic table to look up sodium's oxidation number. So sodium is in group 1, which has a +1 charge. So I'm going to write down +1. The only difference when forming these compounds is that instead of the second part being another atom or another element from your periodic table, it's going to be a polyatomic ion, so where you're looking for it is in one of these charts. So I'm going to look up nitrate. Make sure that you're paying attention to the spelling because there's nitrite and nitrate. So we're looking for this one. And so my formula, instead of it saying just an element name, it's going to say NO, so capital N, capital O, for nitrogen and oxygen, and then a 3 at the end as my subscript. That is the formula for nitrate, and then the oxidation number is given to you right on the ion itself, so it has a -1 charge. So just like when we made these kinds of compounds before, we're going to crisscross their oxidation numbers to tell you how many of them that you need. So this one tells me I need 1 sodium as part of my compound, and this one tells me I need 1 nitrate as part of my compound. And just like before, we don't write the subscript 1, so when I put this together, it's just going to be NaNO3. The other part that I kind of want to preview in here is how easy it is to name these. When you name a compound that has a polyatomic ion, you just use that name. So if you have a compound that's the combination of sodium and nitrate, we would just call it sodium nitrate, and that's it. And then the combination of aluminum and sulfate would just be called aluminum sulfate. So the naming is really straightforward, and it still follows the same rule for transition metals that we talked about last time I saw you, where you have to use the Roman numerals. So if I have aluminum and sulfate, my metal is Al. I would look up its oxidation number on my periodic table. So find aluminum on your periodic table. Aluminum has a charge of +3. And then sulfate is going to be a polyatomic ion, so I look in my chart for it. And sulfate with an ATE is right here. So its formula is SO4, and the oxidation number of -2 is given to you. So SO4 with a -2 charge. We use their oxidation numbers the same way, where this 3 tells me that I'm going to need 3 sulfates, and this 2 tells me that I'm going to need 2 aluminums. But when we write it, since I need multiple sulfates, if I just wrote SO43, that would look really weird. So the way that we show that we need 3 of this entire group is I'm going to put sulfate in parentheses. So I would write it as Al2 SO4 in parentheses, and then a 3 on the outside of the parentheses. So that tells me I need 3 of that whole thing. All right, let's go over calcium and phosphate together. So again, if we named this, it would just be called calcium phosphate. Calcium is my metal, and what is its oxidation number? +2. And then PO4 is my polyatomic ion, that's called phosphate. And what's its oxidation number? -3. So again, please pay attention when you're using your polyatomic ions chart. Pay attention to the letters. They are just one letter away, phosphite versus phosphate, and it changes their formula. And this one has a -3 charge. So with those charges, we crisscross it to tell you how many of the other thing you need. This 3 tells me I need 3 calcium atoms, and then this 2 tells me that I'm going to need 2 total phosphates. So phosphate as a group will go into parentheses, and the 2 goes on the outside. So it would go Ca subscript 3, and then open parentheses, PO4, close your parentheses, 2. So even though there are these extra subscripts in here, we would still just call it calcium phosphate. And then the last example that we're doing this way is potassium and carbonate. So if I have K with a +1 charge, that came from my periodic table, and carbonate, my polyatomic ion, is right here, the first one, sorry, CO3 with a 2- charge. So I crisscross their charges to tell me that I need 2 potassium atoms and just 1 carbonate. When you only need one of them, we don't need to use parentheses since we're not writing that subscript. So this would just be K2CO3, and I would call it potassium carbonate. And then the last example that we'll do is if you are given 2 polyatomic ions. We don't have very many of these because there's not a lot of common positively charged polyatomic ions, but this is one of our examples. So if I have the combination of ammonium and sulfate, ammonium is NH4 with just a little positive sign there. When you see that, it's implied that it's a 1. So NH4 with just a +1 charge. The reason that you don't always see the 1 written is because when you crisscross it, we get rid of that 1 anyway. And then the other part is sulfate, so I would look up sulfate, which we already did. SO4 with a -2 charge. And so the 2 tells you that I would need 2 ammoniums, and this implied 1, or the not number that's there, would tell you that you only need 1 sulfate, and therefore you don't need parentheses on that one. So the first part, NH4, would go in parentheses because I need to put a subscript of 2 on it, and then SO4 afterwards.